In this last video for 6.6, we're going to talk about triangle proportionality theorem. So still a lot of proportions, but just different ways in how you can set up proportions with parallel lines drawn near two triangles. So for the first part, if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. Remember, proportionally just means that it has the same ratio comparing them together. So if you look right here, it pairs up the different sides, RT over TQ, and then RU over US. So just a different way in how you can set up the proportions without having to draw out the two separate pictures for the two triangles. But just remember that's because these two sides are parallel to each other. So the converse, remember the converse is that we flip the order of our sentence. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So in our picture, if we can see that our ratios are equal to each other, then we know that the two lines right there are going to be parallel to each other. Remember, parallel, we use our little triangle symbols, not the congruent symbols. So now how we can do this is we can put an X in for the missing piece, so that's my RQ, and I need to solve for RQ. So remember, I can set up my RQ over UQ equal to RS over ST. So if I put all of our numbers in there, we're going to have X over 9 equals 4 over 6, and then we can cross multiply like we did before. So that would be 36, so my 4 times 9 is 36, and then my 6x, so when I divide by 6, I get x equals 6. So that means that RQ, the length of RQ, is going to be 6. One little side comment I wanted to make is that you can still set up your two different triangles, so drawing the two separate triangles and making a proportion like we did before. That it does take a little bit more time. So this is a faster route if we can see that the two sides we are given are parallel to each other. So for this next one is kind of the opposite, that if we are given some different measurements, so if this piece right here, AB is 33, if BC is 27, if CD is 44, and if DE is 25, we want to check to see are the lines parallel to each other. So is the dotted line BD parallel to AE? So what we need to do is set up the same ratios. So my 27 over 33 and my CD, so my 44 over the 25, and I want to check to see if the ratios are equal. So the reason why we're doing this is if the ratios are the same, so if they are equal, then the lines are parallel. If they're not equal, then the lines are not parallel. So 27 over 33, both divide by 3, so I get a 9 over 11. The 44 over 25 doesn't reduce at all. So these ratios are definitely not the same. So the ratios are not equal. So the line BD is not parallel to AE. Proportional transversals are now, if we don't have a triangle, but we still have these parallel lines going through our figure, we can still set up some different proportions. So if three parallel lines intersect two transversals, then they divide the transversals proportionally. Remember, the transversals are like the lines L and line M. So if you notice the different pieces that they set up, so UW over YW is equal to VX over XZ. So it's similar to if it was a triangle, but it doesn't make a triangle, but you can still pick out the different pieces. So in this next question, we have to figure out which one is not necessarily true. So I'm going to do them in different colors. So my PQ over QR equals UT over TS, and that's pretty much the exact same thing as our definition. So letter B I'm going to do in this green. So TS is over UT, so kind of backwards there, and then QR is over PQ, so that one's kind of backwards, that one still works. Next I'm going to do in pink, so PQ over PR, so the whole length, that would work, over, and then equals UT over US. So notice that those pink lines are set up the same way, so that one does work. Lastly, I'm going to do it in orange, so QR over RS, so that's kind of a little different, that it's going the different direction, and then TS over RS. And that would definitely not necessarily be true, so that's the one that we're going to be circling that does not always going to be working. So for the angle bisector proportionality theorem is using the idea of the angle bisector. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So let's set this up how they've got our diagram right here. So AD over DB is equal to CA over CB. So we can set them up that way. So in this next picture, we're going to do it the same way. So one piece you notice that's missing is this piece right here. But if the whole segment is 15 and this is x, to figure out this missing piece, I would subtract 15 minus x. So that's what I'm going to write, that this is 15 minus x is really that length of QR. So if I set this up the same way as our pink up above, I would have QR needs to be over my RS, and then my PQ needs to be over my PS, and then let's fill in the pieces. So QR is my 15 minus x, RS is my x, PQ is 7, and then PS is 13. So we need to cross multiply and distribute that 13. So we're going to have 7x equals my 13 times 15 minus x. So 7x still equals my 13. Oh, sorry, that'll be 195 minus 13x. And then I need to add my 13x to the left to get my x's together. So we'd end up with a 20x equals 195. When I divide by 20, you are right, that's not going to give me a nice even number, but I will get 9.75 for my x value. And if you notice that that is what the RS is, so RS is equal to 9.75. For these last two questions, we are just going to be reviewing one of the previous problems. So on this very first one, you can see that we need to figure out what the AB length is. So I'm going to label that as my x. Remember, I can set up my ratios any which way. So I could draw two separate triangles, but I'm going to keep them separate. So I'm going to set up my BC over AB is equal to CD over DE. So that would be 18 over x is equal to 24 over 20. And then I need to cross multiply. So I'm taking 24 times x and my 18 times 20. So when I move it on up here, I'm going to still have 24x. 18 times 20 then gives me 360. When I divide by 24, I end up with 15. So AB is equal to 15. Next, for this last one, it's not asking me to solve for anything, but it is asking me, are they parallel to each other? So it's kind of like that shoe shelf one that we did earlier to see if the ratios are equal. So I'm going to set up my BE over BD. So that would be 16 over 10, which reduces to 8 over 5. And then for the other side, I'm going to do AE, because I need to keep it the same, over CA, and that would be 28 over 20. And when I reduce that one, I end up with 7 over 5. Definitely not the same. So since they're not the same ratio, then that means that CD is not parallel to AB again.